is undernourished. And this amount is still above the 2015 levels. So yes, the food production is increasing, but we still have hunger problem. This is related with social justice. And more than 600 million people affected, 2.3 billion people suffer from moderate or severe food insecurity. And some regional patterns, South America and Southern Asia, they showed progress, but some parts of the world are worsening, like Northern Africa, Western Asia. And Africa accounts for 60% of projected undernourished people by 2030. And FAO, the Food and Agriculture Organization, they project that 500 million people will still face chronic undernourishment by 2030. The line is clear. The world produces enough food, but not everyone can access it. Yes, and they have three scenarios, and these three scenarios depend on technological development, climate policies, trade structures, and social equity. And if environmental policies remain weak and inequalities deepen, the system will shift toward this part. And this part makes more environmental and social pressures. So our global challenge remains the food system in a nutshell. They emit a quarter of all greenhouse gases, and there has been a call from United Nations to transform the conventional food system, move beyond mass production, diversify food systems, and empower vulnerable groups, and promote sustainability across the entire food chain. So we need to diversify. We need to make justice in terms of food distribution. And here comes an opportunity with aquatic foods and aquaculture. And they are also called as blue foods. What are they? They are fish and other aquatic foods they present an opportunity for more sustainable diets, and they are recognized at the UN Food Systems Summit as a promising area. They are highlighted as key to building just, resilient, and climate-smart food systems. Why they matter? They matter because they are nutritious and rich in essential micronutrients. They are resource efficient and low in greenhouse gas emissions. They have smaller environmental footprint than most land-based animal foods, and increasingly center in food policy and sustainability debates. This is aquatic foods are a high agenda and hot topic for sustainability food systems. Let's see which SDGs they contribute. The first two, ending hunger and improving health. And also they contribute to environmental sustainability. They also contribute inclusive growth and equality, and some additional opportunities comes with aquaculture. Let's look what are blue foods. They are aquatic foods defined as animals, plants, and microorganisms, as well as cell and plant-based foods of aquatic origin. They include finfish, crabs, shrimps, octopus, squids, clams, sea snails, and aquatic plants like water spinach, algae, and other aquatic animals, insects, and sea cucumbers, and they include like 2,500 species of fish, shellfish, plants, and algae. This is this is a rich area of food and diverse area. They can be, as you know, of course, better than me. They can be farmed and wild caught and are sourced from inland like lakes, rivers, and wetlands, coastal areas, estuaries, mangroves, and nearshore and marine waters, producing a diversity of foods across all seasons and geographic regions. So they are produced through diverse systems from industrial fisheries to small scale fish ponds. So they have a promising way of sustainable food production. And the literature sometimes makes distinctions like two distinct aquaculture production words, like aquaculture developed countries, most of Asia, aquaculture underdeveloped countries like most of Africa, Europe, the America, and Oceania, the rest of the world. And when you see 57% of aquatic production is for direct human consumption. Asia leads production, and China is aquaculture giant here. But Chile, Egypt, and Norway is really should be considered, should be mentioned separately. And Chile is a famous aquaculture country, as you all know. And the consumption doubled in 50 years, now provides 17% of global animal protein, which is over 50% in several African countries. And aquaculture receive more importance. If you look at top 10 countries in global aquaculture, as we know, top 10 countries here, and Chile is at the 8th ranked here. The 8th good country, and Norway is 6th. Yes, and as we see, world fisheries and aquaculture production of aquatic animals and top 10 species, here we see freshwater fishes, diadromous fishes, and marine fishes. They are more capture fisheries, and crustaceans and mollusks, and we have those statistics here. And aquaculture appears to us as an opportunity for sustainable food production because it gives a better climate and environmental performance. So you see the carbon footprint of land versus sea meat. You see the beef, but compare it with shrimp, tuna, salmon, mussels. These are the carbon footprints comparison. It gives a diverse sector, promotes biodiversity by cultivating hundreds of aquatic species, demonstrates production variety through diverse farming systems and practices. And they have this high nutritional value, not only rich in energy and protein, but also provide unique, highly bioavailable micronutrients. So, as we see, as we know, as you know, it's a diverse and interconnected sector. However, global production remains concentrated with only 22 of all species groups farmed in 2070s, and only 22 species group accounted for over 75% of global live weight production. And here it is connected with all ecosystems. Nutrient flows in integrated aquaculture, agriculture system involving fish, crops, and terrestrial farm animals. So the systems are connected with each other. A pathway to low emission nutrition. That's right. We have this Paris Agreement advising us to stay below the 1.5 degrees Celsius with temperature rise. But the food systems contribute to a quarter of this emission, so we need sustainable food production systems. And blue foods, aquatic species, show lower greenhouse gases, as I gave an example to compare a beef with shrimp or tuna fish. Yes. And they have really high nutritional qualities, as you already know, with vitamin B12, vitamin A, calcium, omega-3 fatty acids, iron, and zinc, as you see. And feed composition, we know that you know better. Feed composition affects nutritional quality. So this feed production is really important topic for aquaculture. Lowering aquatic ingredients in feed compositions like particularly fish oil, it has a reduced omega-3 fatty acids. Now we see that, okay, to make feeds for aquaculture, we still need aquatic ingredients, which increases the quality of the feeds. And using food-grade resources like soy, fish meal in feed raises efficiency and equity concerns according to the literature here. And sustainability requires reducing high-quality human edible ingredients, increasing use of waste and non-edible co-products. So this is the dilemma, I guess, for feed production in aquaculture. But let's have a look. Let's have a look how nutrient diversity of aquatic animal source foods in relation to terrestrial animal source food. So you see, these are all aquatic foods. They have high capacity with omega-3, vitamin A, B, calcium, iodine, iron, zinc. But there are environmental stressors affecting aquaculture systems. We need to protect the aquaculture structure, aquaculture infrastructure. Which stressors? For example, the stressors are grouped like stressors impacting production quantity, impacted product quality. Production quality is influenced by climatic stressors and non-climatic stressors. I will give examples in my upcoming slides. And the product quality is influenced by harmful algal blooms toxins, pathogenic and non-indigenous bacteria, heavy metals, plastic contamination. So we need to protect aquaculture, but we need to understand the influence of the stressors. Let's start with warming, rising water temperatures. Higher temperatures can push farm species beyond their thermal tolerance, and they reduce growth and increasing mortality, as we see here. And one of the planetary boundaries was ocean acidification, as I showed in my first slide. Ocean acidification. As you see, lower pH levels weaken shell-forming species like oysters by disrupting their calcium carbonate formation. And the acidification alters sensory behavior and immune responses in finfish. It can reduce the availability of key nutrients and plankton species that form the base of aquaculture food webs. So we want aquaculture to develop, but we are really connected to all these climate influence. What to do if ocean is acidified? What to do? How to protect aquaculture? Sea level rise, flooding and saltwater intrusion can damage coastal ponds, and loss of coastal land reduces the space available for shoreline aquaculture facilities. These problems, these challenges are on our road. The altered precipitation patterns. Heavy rainfall increases runoff, turbidity, and nutrient loading, which can reduce water quality in ponds and coastal systems. And drought decreases freshwater availability, limiting water exchange and increasing salinity stress. And the severe weather events like storms, hurricanes, and typhoons. Strong storms can destroy cages, nets, rafts, and ponds, causing major economic losses and large-scale fish escapes. And hypoxia, oxygen deficiency, low oxygen levels, they reduce fish growth, impair metabolism, and can lead to mass mortality. Eutrophication, nutrient over-enrichment, excess nitrogen and phosphorus cause algal blooms that consume oxygen when they decompose. They are really connected to each other. And the diseases, as you know, bacterial, viral, fungal, high-density farming accelerates disease transmission within facilities according to the literature, and disease outbreaks cause major economic losses, high mortality. And invasions, non-native species introductions, especially escapes from farms may become invasive, competing with native species for food and habitats. And parasites, no need to mention, parasites reduce fish growth and feed efficiency while increasing stress and susceptibility to secondary infections. And here you see harmful algal bloom toxins. This can kill farmed fish and shellfish within hours, and bacteria as well. So, and also heavy metals accumulate in fish tissues and impair growth, reproduction, and immune function. And also, we shouldn't forget the plastic contamination. Microplastics are everywhere now. They are ingested by farmed fish and shellfish, causing inflammation, reduced growth, and impaired nutrient uptake. However, aquaculture may also have some impacts on environment. Let's see their potential interaction with environmental resources. Land use, greenhouse gas emissions, especially in feed production. Energy use and pond methane, nitrous oxide release contribute to the sector's carbon footprint. And fish-derived resource use, infrastructure resource use, they are some of the environmental impacts of aquaculture. For example, seafloor impact. The waste feed and organic matter can accumulate, can escape here and accumulate here on the seabed, and they can degrade benthic habitats. Chemicals such as antifoulants, pesticides, and disinfectants can enter surrounding waters. And the antibiotic resistance can occur. The genetic pollution may also come. Farmed escapees can alter the genetic structure of wild populations. The freshwater use should not be forgotten. Freshwater agriculture systems often require substantial water withdrawals, and the disease spread. High-density farming increases the risk of disease transmissions, and nitrogen and phosphorus emissions may influence the environment. Just a close look why aquaculture produces greenhouse gas emissions. Through several interconnected production processes, while unfed species have very low emissions, however, fed species, fed aquaculture species show higher carbon footprints due to feed and energy inputs. So feed production here, as you see the line, feed accounts for 70% of greenhouse gas emissions in most fed aquaculture species. If you use energy and this energy is not coming from renewable energy, it makes still greenhouse gas emissions. Energy used in farming operations for pumping, aeration, filtration, heating, cooling, they all increase greenhouse gas emissions. These intensive systems, as we mentioned previously, the RAS systems, cage tanks, they have higher electricity demand. And methane and nitrous oxide in pond systems can be produced, and they are also contributors to global warming. This land use and habitat conversion, some farmers, expansions of ponds and feed croplands increases land use emissions. See here, this photo is from dead mangroves in aquaculture pond in a delta. So coastal farmers, because government gives incentives for aquaculture production, with these incentives, some coastal farmers across the archipelago here converted large areas of mangrove forests into shrimp ponds. So this is a real environmental impact. Land conversion releases long stored carbon from soils and vegetation. And freshwater use and evaporation losses are still greenhouse gas emission sources. The infrastructure and material production, for example, in the production stage of these cage tanks, pipes, pumps, they have some embedded emissions, and the processing, transportation, and cold chain of this aquaculture still have greenhouse gas emissions. So here are some values about the carbon footprint of several species like seaweeds, bivalves, and these numbers can be reached from my presentation that we will put to our web page for the project, and Herman will also put it into his web page. So here, the percentage, the sex disaggregated data on employment for the primary sector in fisheries and aquaculture. You see, still male percentage is higher in aquaculture, like in agriculture. And state-of-the-art marine fishery resources, if you look at 38% of the stocks are sustainably exploited. So those stocks should be protected as well. And if you look by volume, 23% of landings from unsustainable stocks. And when I come to conclusion, dear colleagues, the key expectations are here. The seafood industry is expected to grow rapidly, especially in aquaculture. However, sustainable feed development remains a major challenge amid increasing resource scarcity. And future feed innovations must use resources that do not compete with human food. So research and development should be focused more on this area, feed innovations. This shift represents a move towards greater equity and resource efficiency. The climate change challenges both fed and extractive aquaculture species will face direct and indirect climate impacts. Systems must prepare for warming, acidification, and changing water conditions. And there are some climate-smart aquaculture trend should address not only emissions from production, but also the adaptive capacity of aquaculture system to climate-driven change. And there may be a future with our sustainable aquatic food systems, but environmental stressors should not be neglected. And I thank you for listening me. That's the end of my presentation, Herman. The floor is yours.
All right. Thank you very much, Dr. Güray, for your talk. Very, very, very nice. I got surprised with the numbers I didn't know about. So let's see if our audience has any questions or comments, including Cheval. Cheval, you want to ask, you can do too. Also Gulchen, if you want to talk.
Okay.
So let's see. Do we have any questions?
Hi, everyone.
Hello there.
Hello.
Hello. Actually, thank you very much for the presentations for two, not only for Güray. Thank you very much, Mr. Kamil, for the presentation. I have a question to Mrs. Güray, if it's possible. We saw from the presentation that food waste considered one of the reasons about the cannot access food for the people. And is there any global agreement for this or any global activity for solve this food waste problem and to reach all people to reach the food in the time, actually?